Okay, so now we will learn about z-test, which is also called t-test. Now I told you earlier that it is a parametric test, but it also has another use which kind of confuse you, as it is to compare the significant difference between two proportions. Now we will see it in another video, but till then we will use this parametric the z-test for parametric use. So for parametric use, you can use it whenever there is a condition or situation where you have to compare a sample mean with population mean, or you have to compare a value in a sample with that of a sample mean. Now imagine you have an entire population, then a researcher will only bring about only take few people, which we will call sample, and he will calculate mean for this sample. There will be a population mean which is called as mu. For notation, you can refer to this. There is a sample, there is a population. For sample, we use x bar as a notation, and for population, we use mu as a notation. And for standard deviation, we have s for sample and sigma for population. So coming back to this example, in this population, if there was a study that was to compare a sample mean with that of a population mean, then also we can use z-test, as well as within this sample, within this small sample, there will be multiple values, and we have to compare this one value with that of this entire sample mean, then also we can use z-test. Okay. Now parametric use of z-test. We have a 4-step process that we will understand by the way of an example problem. So there was mean weight of babies born in X hospital is 2.3 kg with standard deviation of 0.3 kg. Now find out whether the weight of 1.3 kg baby is significantly different or less. Now please underline this, because there will be two alternate hypotheses for each of this condition. You have to apply alternate hypothesis based on what is given in your question paper from the norm at the confidence level of 95%. So before starting a 4-step process, we have to understand how to identify that the problem can be solved with z-test. Now as we saw above, it is a comparison of a value or sample mean with sample mean where standard deviation is given. So is there a value given? Yes, it is 1.3 kg. Is there a sample mean given? Yes, it is given that 2.3 is the mean weight. So this will be x bar because it is a sample, and standard deviation is also given. Now the stepwise process is as below. So step 1 is to write the alternate hypothesis as well as null hypothesis. What is null hypothesis? It basically nullifies any possibility of getting a positive result. So in this, positive result will be that yes, the baby was actually significantly less weight, had significantly less weight than that of norm. So we will nullify that hypothesis. So we will assume that the weight of the baby and the sample mean are both equal. There is no difference at all. Now I told you to mark this one. So for alternate hypothesis, if question says find out whether there is significant difference, then for difference it can be more or less. So in short, we can say they are not equal. But if it is given that find out whether 1.3 kg is significantly less than norm, then your alternate hypothesis will be x is less than x bar. So based on the situation given in your question paper, you will answer accordingly. Now step 2 is calculation of test statistic. Test statistic is any statistical value that we identify or calculate in any test, be it t-test, z-test or a chi-square test. For z-test, the test statistic is z value. The formula for z value is this one. Now here x bar and standard deviation, it can be also replaced by mu and sigma if you are comparing a population mean with sample mean is compared with population mean. But here, because we are comparing it with sample, we will use this notation. So for this value we will now calculate. So we have x is equal to, first we will write x is 1.3 kg, x bar is 2.3 kg, and s is 0.2 kg. Putting this value here, it will give about 3.3 z value. Now for these z value, step 3 will be comparison with tabloid value. Now what is tabloid value? It can also be 2. Tabloid value is, we were given that confidence level was 95%. Now 95 confidence level means that alpha is equal to 0.05. You can calculate it by 100 minus 95 and then dividing it by 100. And for alpha level of 0.05, there is a methodical approach to how to calculate z value, but this is the most common value that is asked in exams, so you can directly mug it up. And to learn how to actually find out the any value for any confidence interval, there is a separate video, link for which will be in the description below. Now we have a z value that is calculated, and this value is actually more than the tabloid value. We can take any of this tabloid value, it is of no issue. Mostly in exams you can remember 2 as a tabloid value for a 0.05%, 0.05 of alpha, and whenever there is calculated value which is more than tabloid value, it will look something like this. So this is a normal distribution curve, and any value that falls within this realm, they are considered as non-significant. They are considered as non-significant because they fall within the majority of the 95% of samples. And this value here, it was outside of this 95%, that's why it will be considered as significant. So it is a significant value. So what can we conclude from this is that the babies who are born with 1.3 kg weight, they are actually significantly low, their weight is significantly low than that of sample mean, which was 2.3 kg. Okay, so a better way to write this conclusion is that H0 is rejected, because we saw that x is not equal to x bar, it is actually less than x bar, statistically proven at 95% of confidence interval. So x equal to x bar, which was null hypothesis, was actually wrong. So we will write that H0 is rejected and weight of 1.3 kg is significantly less or different from the norm. And this will mark the end of this problem. Now in summary, we can say that there are 4 steps. In first step, you will write the hypothesis, null hypothesis as well as alternate hypothesis. Second step is calculation of z, which can be either of this. Third step is comparison with tabloid value, and fourth step is conclusion. So there is this practice problem that you can try it out based on above 4 step method. Find out whether wait time of 68 minutes for bus going from Bombay to Goa is significantly different than regular average wait time of 56 minutes. Standard deviation of the wait time is 9 minutes. Now z tabloid value is already given as 1.96, so use that, and the answer I provided in description. Please try it out.